So when you get your, and again, I'll give you your unit circle back, the one that's been graded. My advice is the first thing you want to do is go to your unit circle and fill in the information that's not already on there. So for the quiz, we didn't add in that all students take calculus. We put the positive and negatives in terms of x and y. So you might want to do that. That helps you with your trig functions of any angle, like from 4, And then I would go around and do the tangents. So the tangents or just write it off to the side somewhere. Anything that's over 3 is your root 3, and anything that's over 6 is root 3 over 3. That's a 3. And then your over 4s are 1s. So hopefully that saves you some time, right? Even if you only did it in one quadrant and you knew the other signs, then you should be okay. And then the other thing I would do is add in your negative angles on the bottom. So this is negative pi over 6, negative pi over 4, negative pi over 3. And then do something to help you remember that these two are your sine and your tangent when it comes to inverse, sine and tangent. That should be backwards, but you get the point. And then these two would be cosine. So if you even just took a minute to do that, it's going to help you when you get to the 1, trig functions of any angle section, 2, the inverse function section for the last one. Yeah.
Do you have to put negative pi over 6, negative pi over 4? Like, why can't? Oh, wait.
You restrict domain. You have to. So that's a good question because it doesn't seem like you should have to. I should just give the other angle, but it will be wrong.
Because that means you have to go home.
Exactly, and you can't skip, right? You can't say, okay, I'm going to take from first quadrant, I'm going to skip second quadrant. It's got to be one fluid arc, and the only way to do that is negative pi over 2 to positive pi over 2.
For tangent, it's also you still switch them.
What do you mean switch them?
Like negative pi over 6.
Yes, tangent and sine are both negative pi over 2 to positive pi over 2. And then cosine is 0 to pi, first and second quadrant.
Thank you.
You're welcome. So if you do that, then these questions should be relatively easy, 1 and 2 anyways, right? So 1 is cosine negative 1 of negative 1. So I'm looking for where on my unit circle, my cosine is negative 1, but again, from 0 to pi. So where does that happen? Pi. And you always want to answer these in radians. Inverse trig functions are in radians. Number 2, find the sine, or the exact value of tangent negative 1 of negative root 3. So we said the over 3s are your root 3s, right? And if it's negative, that means negative pi over 3. And then number 3 says find the exact value of cotangent cosine negative 1 1/2. So I would say in something like that, there's actually 2 ways to do it. One is use your unit circle because 1/2 is actually a value of cosine on your unit circle. And the other is the right triangle trig, because sometimes it's not going to be a value that is on your unit circle. If that said cosine of 3/4, let's say, I'd have to set up the triangle, okay? But we'll do both ways because you have that choice. So if I said cosine negative 1 of 1/2, I'm looking for where my cosine is 1/2, which happens here at pi over 3. And then I'm asking for the cotangent at pi over 3. Cotangent's adjacent over, adjacent over opposite if you're using a triangle. But it is x over y. Root 3 over 3, right? You're going to take that root 3 and flip it. Or do the x 1/2 over the y. Keep, change, flip. There's a lot of different ways to do this. 1 over root 3, which is root 3 over 3. The other thing is realize that these two would be flipped for tangent, right? For cotangent. If the tangent of over 3 is root 3, then the cotangent is root 3 over 3. And if the tangent of over 6 is root 3 over 3, then the cotangent is root 3. It's the reciprocal of them. They are. It's a lot of 3s, but it's the reciprocal. So that's your answer. Root 3 over 3. The other way to do that is set up a triangle because it works both ways. So if I set up a right triangle, and that's not a line. Yeah? And I put theta in the corner, cosine is adjacent over hypotenuse, and then I would get 1 squared plus x squared equals 2 squared. 1 plus x squared equals 4. X squared equals 3. X equals square root of 3. And then cotangent is adjacent over opposite, 1 over root 3, which gets rationalized to root 3 over 3. So for questions like those, you can go either way, triangle or unit circle, if the value is on your unit circle. If the value is not, you have to do it the triangle way. Carlos.
Do like 1 and 2
Say again.
Can't you do
Sure. Well, I mean, you can do any of them. It's just that your angles in your triangles, most people know that, well, not 1 because it's pi, it would be 180. But for root 3, the way that you guys know your triangles, most of you, are 30, 60, 90s. So as long as you can then take that 30, 60, 90 and make it pi over 6 and pi over 3, and then also apply your restricted domain from negative pi over 2 to positive pi over 2, you're good. It just, in my opinion, that takes longer. Because you'd have to know, so number 1, you can't get that way. Number 2, you'd have to know that would be a 60-degree angle, and the 60-degree angle is pi over 3. And then you'd have to know, because it's negative, that it's in the negative quadrant, which would be negative pi over 3. But you can do it that way. Somebody else had their hand up. Emily.
Okay, if you're doing the triangle and it says tangent, cotangent, and there's a negative fraction, how do you know which one?
It doesn't matter. It doesn't matter because so if you're doing inverse functions and it's negative, it's in that negative quadrant, which would be down here. So that angle won't matter. Yeah, it won't matter. Because you're either going to get root 3 or you're going to get root 3 over 3. And then if it's negative, it's the over 6 and over negative over 6 and negative over 3. Any other questions on 4, 7? Okay. All right, so this is one. As soon as you see 12 and 5, I mean, tangent, the only things you can use your unit circle for are 1s, root 3s over 2s, root 3 over 3, and root 3. As soon as you see it's none of those values, this is your hint to set up a triangle. So if I set up a right triangle, put theta here, tangent's opposite over hypotenuse. What other information did it give you? It gave you the quadrant?
Yes.
Thank you. Which one?
Well, because since it's negative, that means because of the restriction has to be in the 4th quadrant, meaning that the 12 has to
But it didn't give it to you, right?
No.
You have to know that, right? So we know that the tangent is restricted to 4th and first and 4th quadrant, right? So we know we're restricted there, which means that technically my picture's not right. It should be flipped upside down, okay? But you get the idea that the tangent would be a forward x but a down y, which means the 12 is negative. And then 5, 12, and 13, I promise you, if you remember your triples, it's going to help you as far as time goes. You'll get at least one. 5, 12, 13 is one of them. So then cosecant is the reciprocal of sine, hypotenuse over opposite. Hypotenuse is 13 and opposite is negative 12.
Do you want to just close it?
No.
I didn't.
Quick overview. Oh, or not. So, real quick, since we're kind of short on time and I don't want to take up all the time. It's been a long time since you went through the notes for 4.1 and 4.2. I make sure that I'd go back through that stuff. 4.1 was all the conversion from radians to degrees and degrees to radians. It was converting, it was coterminals. This was all coterminals. Okay, it was complements and supplements. It was degree, minute, second notation. And it's not going to be find the degree if I give you 37 degrees, 27 minutes and 15 seconds. But it will be find sine or cosine of an angle that is given to you in degree, minute, second. So make sure you know how to get it out of it, or make sure you know how you use it in your calculator. You don't even necessarily have to get it out of it. You just have to be able to type it in it. So if I hit sine of 32 degrees, 15 minutes and 22 seconds, you should be able to get a value. Okay. And then the length of the arc was in this section, which is that SOR formula, S equals. And the thing about the arc length is that it has to be in radians, right? So it'll give it to you in degrees. You have to make sure that it's put back into radians. So that was, other than just multiplying numbers out, that was the only catch to length of the arc in 4.1. And then in 4.2, we got introduced into the unit circle. So 4.2 is all unit circle related. How to fill it out, and then how to apply it so that the x is your sine, your cosine, the y is your sine, the y over x is your tangent, all that sort of stuff. I'm going to give you back your unit circle again for your test, but make sure that you know how to apply it, because I'm not going to just say, give me the sine of 4 pi over 3. It's going to be a coterminal angle or something that you have to apply based on your unit circle, okay? And then for 3 was your right triangle trig. And this is your SOHCAHTOA. So setting up a right triangle, finding the missing sides using the Pythagorean theorems, and then also the word problems came in that section. So, like you're looking at a tree, the angle of elevation, all that sort of stuff. Those were for 3. And then your triples are in here. So 3, 4, 5, 6, 8, 10, 5, 12, 13, 8, 15, 17, 7, 24, 25. Those are the most common ones, and those are the ones that are going to seriously save you some time if you know them, so that you don't have to do the Pythagorean theorem and try to find the square root of 289 to be 17, because that's not that obvious. And you won't have a calculator for the ones that need triples. You'll have a calculator for the right triangle trig word problem because you need it. But if there's special angles, you won't. So just keep that in mind. And then 4-4 was trig values of any angle. So this is where we started to use reference angles. You know how to find reference angles. You need to know how to apply. All students take calculus so that you know where an angle is located and then what its sine should be, that kind of a thing. You need to know how to get from something like 11 pi over 3 into a mixed number to know where that's located, to know what signs it should be, positive or negative. So those are going to be, again, your coterminals that are on your unit circle. The reference angles are on your unit circle, but the originals are not. So you're going to learn how to apply that into there. And 4-4 was where your displacement word problem came from. Like there was a weight hanging from a string, and I gave you the trig function, and I said, what would the location of it be at t being, I think it was like a half a minute or a half a second, something like that. And all you have to do is take and plug in a value and then find it. And then 4.5 was your sine and cosine curves. You're going to want to make sure that you are a master at those. 4.6, tangent, cotangent, secant, and cosecant. So of those 5, you are only going to get lucky and avoid one, because you're either going to get a sine and a secant, which is going to make you do the cosine, or you're going to get a cosine and the cosecant, which is going to make you do the sine, and then you're either going to get the tangent or the cotangent. So you're getting 3 of those, okay? But obviously, if I gave you sine, I'm going to make you do secant so that it makes you do the cosine. And there will be phase shifts, there will be period adjustments, there will be vertical shifts, there will be reflections. You got to make sure you look for it all. And then 4.7 is where we finished on Friday, and that was your inverse trig functions. So we talked about that at the beginning of today. Make sure that you restrict your domain for tangent and for sine from negative pi over 2 to positive pi over 2. And for cosine from 0 to pi. And then I would add on my tangents onto my unit circle so that stuff is super easy. And arc sine is the same thing as sine negative 1. Arc cosine, same thing as cosine negative 1. Arc tangent, same thing as tangent negative 1. And if it's not on your unit circle, then you set up a right triangle. And you figure out what missing side is, and then you go from there. Questions on expectations for your test? Do not forget your calculators. Emily?
Do you need to know how to graph the inverse trig function?
No. The question was, do you need to know how to graph the inverse trig function? And no. The answer there is no. Everybody else is good? Monica? Know how to find reference angles. So if I said 11 pi over 3, you should be able to give me that the reference angle is pi over 3. Or if I gave you 200 degrees, you should be able to tell me the reference angle is 20 degrees. It's the difference from that angle to the x-axis.